Hey everyone, welcome back to the channel. In this video, I'm going to be continuing my feasibility studies for the real world project that I'm building for my business in Microsoft Fabric using AI first approach. In the last video, I said that in the next one, I'm going to be focusing on the visual layer. Actually, not going to be focusing on that. I'm going to be parking that slightly and coming back to it a little bit later in the series. I have done quite a lot of investigation into the visual landscape of Fabric, and it's too big, I would say. The options available to us now are too big. So rather than go into a lot of those and kind of derail the series a little bit, I'm going to skip that slightly and we'll come back to it after we've built a lot of the core data platform for this project. So instead, what I want to focus on, I've kind of squeezed in one last feasibility study before we actually start building. Probably lots of you are thinking, just start building already. But there is some method to this madness. In this video, I'm going to focus on open mirroring. As you might have remembered, we've been doing a few different feasibility studies in this series so far into the ontology, right? Because these are slightly outside of what is the norm on a Fabric project today. Okay, so I wanted to explore how feasible they were to integrate them into my own project. Ontology also looked a lot at DuckDB and DBT for the transformation layer, this part here. And in this video, I want to focus a little bit further back on this part here. So how do we get data from sources into our raw layer, into that first delta layer, as it were? And one of the features that Microsoft have released to help with this is open mirroring. So this is kind of like a subset of the whole mirroring family in Fabric. Open mirroring specifically is where they provision a landing zone, which is essentially just a URL, and you can write files into that landing zone from any application. It's built for sources that don't have a mirroring supported capability. I think that's what it was intended for. I'm bending those intentions slightly because I want to use it as an ETL tool, so that I'm going to use some sort of like Azure Functions or something where I can run Python. The reason being is that nearly all my data sets in my business are not in a database. They're coming from REST APIs. They're SaaS applications that might have REST APIs, or scripts that I want to write data locally to my landing zone from, which don't really have a proper connector. Okay. Now, because that's very relevant to my business, this is very specific to my business and the types of data sets that I have, I think open mirroring could be a really good solution for me. There's some other benefits with mirroring, like once it's set up, the compute is free. You also get some storage free. I think the last time I checked, it was 1 terabyte for each SKU that you're using. So if you're using F8, then you get 8 terabytes, I think, of free storage, which is really useful. And probably one of the biggest pros is that it's quite low friction. You just send files into a landing zone, and as long as they have the right structure, then they're going to get basically converted into Delta tables. And from there, I can use it for the rest of my architecture. So there's a lot of pros, but I hadn't actually used open mirroring in a proper solution before. It recently turned GA, or a few months ago. So I thought now is a good opportunity to really stress test open mirroring, understand properly how it works, and understand if it could be a good candidate for this landing zone part of my architecture. So that led me to these core research questions. I want to know what the setup steps are, how to get started with it. I want to know, can we send data to the landing zone through a service principal? I wanted to understand the structure because I know that it needs to be in a very specific structure, but I wanted to explore that in a bit more detail. How rigid is that structure? And we'll look at that in a minute. I also wanted to look at, if I've got multiple different sources, what would be the best structure for that landing zone? We've got files and they get converted into tables. Can I introduce schemas to kind of break down, to subdivide my landing zone, to make it a little bit cleaner, let's say, and break it down by source rather than having, if I can avoid it, I don't really want to have multiple open mirroring instances, like one for each source, for example. That's overkill for my use case. Then, because we're integrating this into an existing architecture, let's say, how well would this integrate with my DBT workflow that I've been working on? How does the mirror fit into existing version control and deployment? Okay, so this is another question that I had. How would you deploy and manage your open mirror through CI/CD, including things like schema evolution? So if I wanted to add new data sets into the landing zone, how would that work? If I wanted to update the schema for an existing data set in my open mirror, what would that look like as well? So these are all of the core research questions that I tackled throughout this stage. Ultimately, the question I want to ask and answer is, can I use open mirroring for the landing zone for this raw bronze layer in my architecture? Before we get started, this is very simply how it works. So you've got various different source systems. It can even be a database, pretty much anything, right? The benefit is that if you can query the data from code, in my example, I'm going to be using Python scripts most likely. If you can read that source system through code, then you can get open mirroring to work for you. The open mirroring landing zone, when we provision it in Microsoft Fabric, let's just go and have a look at that now, actually. Okay, this is one of the landing zones that I used in my feasibility studies, just from checking it out. And you can see we've got this replication on or off. It's also got OneLake security available now. You can upload files directly in the UI, which is not something I did. But crucially, you get this landing zone, right? So that is the URL where we're going to be sending our data to. When we send the data, it populates them in these folders. So you can see I've got like a school schema, a YouTube schema, just because I was playing around with different structures to see how that schema definition worked. And in each one, I've got a data set like videos in here. And I've just sent raw Parquet, which is one of the supported file formats. So now that we've looked at the landing zone, this is essentially all it is, right? You write files into the landing zone. And if you've got them in the right format, it's going to manage this conversion process into tables here like this. So it's quite simple. That's all it is, really. Let's look at some of the questions I want to answer and open this up in Visual Studio Code, where I'll talk through the research process and the outcomes. Okay, so I'm now in my Fabric BMAD project that I've been working in throughout this project. It's the BMAD one, and we've got a lot of different feasibility studies, the DuckDB one, the ontology one, and I just created a new folder for open mirroring. Again, it's got some helper Python functions to help me interact with open mirroring and to write files and to test the writing of files to an open mirroring landing zone just from Visual Studio Code. Happy to put these on the GitHub as well. I'll leave a link in the description. But this one was quite easy. There were just a few different studies that I did, like how to set it up and ingest data, understanding the format and the schemas. And for each of these, I've got like separate scripts that I generated with the help of Claude as well. Just to kind of stress test, work with Claude to understand open mirroring in more detail and see if it was a good candidate. All throughout that process, I kept these study notes or session notes, and I had the plan here, which is essentially what I did. So here's what we basically went through. We created a new mirrored database. I grabbed the landing zone URL. I made sure that mirroring was started. And then what I did was I generated a service principal in the Azure portal and set up the authentication using the Azure.identity Python library, essentially. Once I had all of that set up, then we can start testing, sending data into the landing zone. Okay. So this open mirroring operations was essentially what I used. And this comes from the Fabric toolbox. So Microsoft have provided an SDK for interacting with open mirroring solutions. And so that became the basis of my own solution as well. Again, I'm working with Claude here. So it's basically a local version. It's not on PyPI, by the way, this open mirroring SDK. So that's why I kind of decanted it into my local project, into these clients for authentication, config, the mirror API, and open mirroring. Then I explored different data structures. So breaking down the landing zone into different schemas. And I found that it was possible to do this using this syntax here with the .schema syntax. So we can break it down into different schemas. Then we've got different tables. For each table, you need this metadata.json file. And then we can start writing in CSV or Parquet. Because I'm probably going to be using Python scripts to write my data into the landing zone. Not sure how they'll be hosted yet. Likely going to be either user data functions or Fabric notebooks. But we'll see. It could also be Azure functions, but we'll see. We'll see how we get on with user data functions. I wanted to understand the column structure and also what this metadata JSON consisted of. Bare bones, you need the key column, because what open mirroring is going to do, it has the ability to do like incremental updates. So it needs to know which columns are the key columns for looking at these incremental updates. We've also got some other things like file detection strategies and is upsert default row marker to true? Quite important. This row marker column is very important. So then I explored the file structure that's needed. Because obviously you're going to have your own data in that Parquet file. Maybe you've got 10 columns coming from your source system. You need to add on this final column, row marker. And there's a few different values. 0 is going to be insert the row. 1 is going to be update. 2 is going to be delete. 4 is going to be upsert. So this is really, really important. And you essentially need to calculate this yourself. So you need to know this from your source system, whether it's an insert, an update, a delete, or an upsert. So you do, with open mirroring, have to do that yourself. What I would quite like is if Microsoft offered that as a feature of open mirroring. Maybe it would be a bit more tricky to implement for them. But what would be really nice is just to throw data at the landing zone. And then I guess it introduces some edge cases that they're trying to avoid. But yeah, I think that would be quite useful. Either way, I had a better understanding of the structure of the files and how I need to be writing them into the landing zone. I was also interested in schema evolution. So say, to continue that example, if we had 10 columns and the row marker, what if I wanted to add in a new column to make it 11 plus the row marker? What I found was that schema evolution is pretty easy. We can add a column, adding it to the next file, and the mirror is going to add the column to the delta table. All of the old rows get 0, and there's 0 downtime. So that's pretty good. The dropping of a column is not probably something that I'm going to do and would do a bit more carefully here. But old rows keep their values and new rows get null. To actually remove it, you need to drop and recreate the folder. So that's going to obviously remove all of your historic data. I was also interested in changing a column type, so drop and recreate the folder. Cannot change type in place. Replication stops with schema merge failure on any type drift. So you do need to be very careful about your types. You can't change types. Again, this is going to require a drop and recreate. So say you have a key that's a string and then you want to convert it into an integer. It's not going to like that, essentially. Again, renaming of columns or tables, not good for open mirroring. What I did was got it to write out this landing zone format. And again, I can share this document, but essentially this is to give to my LLMs when I'm writing the Python scripts to get them to understand a little bit more about open mirroring, because they probably haven't been trained on open mirroring, just to understand how they should be writing their code to interface with an open mirroring landing zone, which looks a little bit like this. Read this before writing a producer that pushes into a bronze mirror. So this was written specifically for my LLM agent that's going to write data into that landing zone, basically condenses everything that we learned throughout this process and packages it up really nicely. And this is a workflow that I've used multiple times with Claude, and I get really good results from it. So that's how we're going to move into the development phase. Go from research into real development, but we're going to hand over these sorts of really dense research documents, documenting all the things and the gotchas that we found throughout the research phase for Claude. We answered the one mirror versus many. Obviously, there's a lot of benefits to just having one. And once I saw that you can subdivide your landing zone by schema, that was pretty much the clincher. So that is probably how I'm going to subdivide my landing zone like this. Each producer owns a schema, and table governance and SQL Analytics namespacing mirror this layout. So it kind of makes sense. Then I was interested in understanding how DBT would fit into this architecture. If you remember, our DBT configuration essentially looks at a raw layer, writes transformations into this gold layer. Now, there are some like staging tables in between, but that's roughly how it works. So if we have these producers writing data into this raw layer, I was pretty confident that it would work, but I was just wondering how the two would marry up. And if DBT could read into this raw layer, given that it's a mirrored database and not like a lakehouse. But the tables are in one lake. So again, they have ABFS paths that DBT can read from. So that was another tick. On the CI/CD point, fully supported open mirroring. So when you commit and you deploy an open mirror, similarly in a way, I guess, to lakehouses, nothing really gets deployed, just the shell of that item. So none of the schemas, none of the tables, none of the files, which is kind of to be expected. Same with Git integration. As I always say, if it doesn't get checked into Git, it normally doesn't get deployed in Fabric. So when you deploy a open mirror to your test environment or to a new environment, the next time that you run, it's going to populate the schemas and the tables again for the first time. So it does not auto start after deployment as well. But I think recently they have added hooks or REST API endpoints to allow us to do that. So we can deploy and then call the REST API endpoint to start the mirror. So that was it really. Quite short and sweet, this one. As I mentioned, I'll put all of the GitHub links so you can have a look at some of the code. But if you're looking at using open mirroring, then I'll definitely recommend it. It's quite a nice solution, to be honest. And I'm hoping to use it for my project. So once we get into the build phase, I'll show you a little bit more detail about how it works in practice. But thanks for watching. I hope you enjoyed that one. In the next video, we're going to be starting to make decisions about all of these feasibility studies, and I'll show you the proposed architecture for my solution, how all of these things are going to tie together, and then after that, we'll start building. Thanks very much for watching. I'll see you in the next one.